we're looking at a question that is a dilution question from the buffers. And the way I know that is that, first off, there's a whole bunch of numbers in it, but it describes a solution of ammonium bromide. So we've got NH4Br. And it gives me 12.8 mils and 2.20 molar of him. All right. And then the other compound it gives me is ammonia. All right. And the descriptive numbers for ammonia that it gives me is 0.0128 liters alongside 3.14 molar. All right, so here's my values. So we're going to be mixing these together, and what I can see is that it's definitely going to be a buffer because I've got my weak base here, and look, that NH4 hidden in the salt is the conjugate acid. So what I want to do is figure out, once they're both added into a beaker together, what the molarities are, because that's what would go into the Henderson-Hasselbalch equation. All right. So in order to do that, since they're mixing, we're going to dilute and use M1V1 equals M2V2. All right. So let's track the ammonium ion first. All right. And we're going to say, all right, well, his starting molarity was 2.2. All right, 2.20, sorry. And his starting milliliters is 12.8. All right, and I'm going to set that equal to, all right, now look, it's trying to be tricky here. Do you see how we've got milliliters and liters? So this value of liters is trying to be problematic. I've already started using mils, so I'm just going to convert this to mils. Some of you get confused because you're like, wait, I thought molarity has to always use liters. I mean, if you're calculating molarity, it does, but since this is an equality here, as long as the volumes are in the same units, then it's going to give you the same answer. So what I'm saying is you can convert this to liters so it matches that, or convert this to milliliters so it matches that. It doesn't matter. But what I'm going to do is convert this to milliliters, all right, by sliding to the right 1, 2, 3 times. So it's really 12.8 mils. Anyway, I'm looking for the other molarity here, the molarity of the solution once it's all in a buffer. But this V2, the ending volume, is going to be these two numbers added together. So it's going to come out to 25.6. All right, you can see that they're the same number, right? It's an equal volume of each. All right, so if we solve for this here, we'll get that X is equal to 1.1 molar. All right, so there's the molarity of the NH4. So now let's run those same values for the NH3, all right, using his values. So the starting molarity there was 3.14. There's M1. The starting volume is 12.8 mils. That's V1. We're going to find the molarity of him. And, of course, the final volume is 25.6 since we mix them together. All right, solve for X using your basic algebra skills, and you'll get a molarity here of 1.57 molar. So now I've got the molarities of each part of the problem. And we can plug and chug into Henderson. We have a constant value a constant KB value that you need to know that you maybe memorized by now. All right, 1.8 e negative 5. So we'll use that for our plug here as we say, all right, well, it's a KB, so that's inherently going to give me a POH is equal to the negative to PKB, so that's negative log of the KB, which is 1.8 e negative 5. Following the equation plus the log of the ion over the weak sample. So there's the ion, and there's his value, so it's 1.1. Here's the weak sample, there's his value, 1.57. All right, so we can plug here and go negative log of 1.8 e negative 5 plus the log of 1.1 over 1.57. I hit something weird, I guess. Oh, I didn't close my parenthesis. Sorry, typing again. I don't know. I actually don't see where I put in a weird thing. Oh, yeah, I do. Look, I didn't close the parenthesis from the first expression. So, anyways, let's close that parenthesis and then add it to the log, my bad, of 1.1 over 1.57. Are you kidding me? My battery died in the video. Well, it's a longer video than it was supposed to be. Congrats. Hey, look, a number, 4.590. I did nothing different, I promise. This problem doesn't want POH, it wants pH. We know those are going to equal 14. I get 9.410.